everybody, so today I'll be explaining the concept of redox reaction. Redox reaction is a chemical reaction that involves both oxidation and reduction. They can be defined based on four things, which is the transfer of electrons, transfer of oxygens, transfer of hydrogens, also changes in the oxidation number. Oxidation is when something loses electrons or gains oxygen, and reduction is when something gains electron or loses oxygen. Oxygen transfer. Oxidation happens when a substance gains oxygen, while reduction is when it loses oxygen. In this example, CO react with Mg to form Cu and MgO. CO is reduced because it loses oxygen, while Mg is oxidized because it gains its electron transfer. Oxidation means loses electrons, while reduction means gains electrons. For example, Cl2 react with I- to form Cl- and I2. Cl2 gains electrons, so it's reduced, while I- loses electrons, so it's changes in the oxidation number. The oxidation is when the oxidation number increases, where reduction is when the oxidation number decreases. For example, is a reaction between sodium and chlorine. Sodium oxidation number goes from 0 to +1, so it's oxidized, while chlorine oxidation number goes from 0 to -1, so it's reduced. Finally is hydrogen transfer. Oxidation is when a substance loses hydrogen, while reduction when it gains hydrogen. In this reaction, Cl2 react with hydrogen ion to form HCl and iodine. Cl2 is reduced by gaining hydrogen, while I- is oxidized by losing hydrogen.
So next, oxidation number of element in compound. Oxidation number is the number of charges the atom will have in a molecule in ionic compound if electrons were transferred completely. So we look at the example. Barium, the oxidation number charge 2+, and sodium, the oxidation number charge -2. So next, chlorine, the oxidation number is 0, and the silver oxidation number also 0. The chlorine is a pure element and silver also a pure element. The rules to determine oxidation number. General rules. Number 1. For an atom in its elemental form, the oxidation number equal to 0. Number 2. For a monoatomic ion, the oxidation number equal iron charge. Number 3. The sum of oxidation number values for the atom in a compound equals 0. The sum of oxidation number values for the atom in a polyatomic ion equals the ion charges.
So this table helps you find the common oxidation number for different elements across the periodic table. What is the oxidation number of carbon in Na2CO3? Sodium is +1 and there are 2 of them, so it becomes +2. While oxygen is -2 and there are 3 of them, so it becomes -6. So Na2CO3 equals to 0, 0 equals to 2Na plus 1C plus 3O. And you substitute the oxidation number of sodium and oxygen in the equation, and you get the oxidation number for carbon is +4.
Function of a reducing agent is to cause reduction to happen to another substance. While doing so, the reducing agent will itself be oxidized because it loses electrons during the reaction. On the other hand, an oxidizing agent functions to cause oxidation to happen to another substance. At the same time, the oxidizing agent will itself be reduced because it gains electrons during the process. To make it simple, remember that the oxidized substance is the reducing agent and the reduced substance is the oxidizing agent. In a redox reaction, there are 2 important species which are called the reducing agent and the oxidizing agent. A reducing agent is a species that is oxidized itself and acts as an electron donor. Meanwhile, an oxidizing agent is a species that is reduced itself and acts as an electron acceptor. The second example is the reaction between ammonia, NH3 and bromine gas Br2. So the equation is 2NH3 plus 3Br2 produce N2 plus NHBr. So in this reaction, ammonia acts as the reducing agent because it is oxidized to nitrogen gas N2, which means ammonia loses electrons. At the same time, bromine acts as the oxidizing agent because bromine is reduced to hydrogen bromide HBr, meaning bromine gains electrons. Therefore, in this example, the reducing agent is ammonia and the oxidizing agent is atoms in CuO are reduced to copper metals, which means they gain electrons. In short, the reducing agent is hydrogen and the oxidizing agent is copper 2 oxide.
Some equation for oxidation reduction reaction can be balanced by inspection. For example, easier to balance with the half reaction method. Based on this principle, all electrons lost in oxidation half reaction must be gained in a reduction half reaction. Half reaction, a unique equation to describe either gaining or losing electrons during redox reaction. Balancing redox reaction in acidic medium. Separate the reaction into half. Reaction determined on the oxidation number for species undergoing redox. Number 2, balance atoms and charges in each half reaction. Number 3, multiply each half reaction by an integer. Number 4, add the half reactions together, cancelling substance that appear on the both sides. And the last one, check that atoms and charges balance. Balancing redox reaction in basic medium. This balancing similar steps as acidic medium, which is one additional step needed. Number 1, add one hydroxide ion to both sides of the equation for every hydrogen present. Number 2, the hydroxide ions on one side are combined with hydrogen plus to form H2O. Number 3, hydroxide ions appear on the other side of equation. The last one, excess H2O ions are cancelled.